is Alda with student ID number G501244034. Now, I'm going to make a reaction video and explain the content of the video I watched in a simple way. So, I will watch the video first. Let's go!
Feel so happy. So very happy. StatQuest. Hello, I'm Josh Starmer and welcome to StatQuest. Today we're going to be talking about the difference between probability and likelihood. These are two closely related concepts that are very easy to get confused. Even I mix them up from time to time. So enough of this jibber-jabber. Let's get down to it. For me, the easiest way to understand the difference between probability and likelihood is to just see it in pictures. So let's start by looking at probability with respect to a normal distribution, keeping in mind that this concept applies to all continuous distributions. In this case, let's imagine that this is a distribution of mouse weights. It has a mean of 32 grams and a standard deviation of 2.5. On the low end, we have 24 grams, and on the high end, we have 40 grams. The probability that we will weigh a randomly selected mouse between 32 and 34 grams is the area under the curve between 32 and 34 grams. In this case, the area under the curve is 0.29, meaning there's a 29% chance a randomly selected mouse will weigh between 32 and 34 grams. Mathematically, we say this with the following notation. The probability of weighing a mouse between 32 and 34 grams, given the mean of the distribution is 32 and the standard deviation is 2.5. And all this equals 0.29. This is the equation we change if we are interested in different mouse weights. For example, if we wanted to know the probability of a mouse weighing more than 34 grams, we would change the bit on the left side to reflect this. The right side, which defines the shape and location of the distribution, stays the same. So when we talk about probabilities, we are talking about a distribution that's described by the right side of this equation, and the area under the curve that is described on the left side. Using the same distribution, we can change the left side to get a new probability. Bam! Now that we have probability worked out, let's talk about likelihood. To talk about likelihood, you assume that you have already weighed your mouse, or mice, if you've weighed more than one. So here's our mouse. It weighs 34 grams. The likelihood of weighing a 34-gram mouse is this point on the curve, and that value is 0.12. Mathematically, we say this with the following notation. The likelihood of a distribution with mean equals 32 and the standard deviation equals 2.5, given we weighed a 34-gram mouse, and all that equals 0.12. If we shift the distribution over so that the mean was 34 grams, the new likelihood would be 0.21. So with likelihoods, the measurements on the right side are fixed, and we modify the shape and location of the distribution with the left side. Double bam! In summary, probabilities are the areas under a fixed distribution, and mathematically, we have the probability of data given a distribution. Likelihoods are the y-axis values for fixed data points with distributions that can be moved. Mathematically, this is written as the likelihood of a distribution given data. If you want to see the actual equations, check out the StatQuest that derives the maximum likelihood estimator for the exponential distribution. Hooray! We've made it to the end of another exciting StatQuest. If you like this StatQuest and want to see more of them, please subscribe. And if you want to support StatQuest, well, consider buying my original songs. The link to my Bandcamp page is down below in the comments. Alright, until next time, quest on!
Okay, this material summarizes the explanation presented by Josh Turner in a StatQuest video, where he discusses in depth the difference between probability and likelihood, two concepts that are often confused, even by people with experience in statistics. Josh emphasized that while the terms are related, they serve different purposes and operate in opposite directions. Josh begins by illustrating probability using a normal distribution. He used an example distribution of mouse weight with a mean of 32 grams and a standard deviation of 2.5. In this distribution, most mouse weighs fall between 24 and 14 grams. Probability in this context refers to the area under a fixed curve. For instance, if we want to know the probability that a randomly chosen mouse weighs between 32 and 34 grams, we calculate the area under the curve between those values. In this example, the probability is 0.29, meaning that there is a 29% chance of selecting mouse in that weight range. What is important about probability is that the distribution parameters remain fixed. The mean stays 32 and the standard deviation stays 2.5. What changes is the range of values we are asking about. If we instead want the probability that a mouse weighs more than 34 grams, we simply adjust the data range of the left side of the equation. While the right side, the distribution stays the same. Josh highlights this probability always refers to the probability of data given a fixed model or distribution. He then transitions to discussing likelihood, which flips the idea of probability around. Instead of asking what is the probability of this data under a fixed distribution, we now ask how likely is a particular distribution given the data we observed. And to explain this, just use a mouse weighing exactly 34 grams. Here, the data point is phased on the x-axis. The likelihood is represented by the height of the curve, the y value at the point for any assumed distribution. Under the original distribution, mean 32, standard deviation 2.5, the height of the curve at 34 grams is 0.12. That value is the likelihood of observing 34 gram mouse given that distribution. But if we shift the distribution, say by making the mean 34 instead of 32, the day increases to 0.21. This demonstrates that likelihood evaluates which distribution makes the observed data more plausible. In likelihood, the data point is fixed and the distribution parameter is moved. So, just summarize the difference clearly. Second, probability, area under a fixed distribution for a range of possible data, and likelihood, height of the curve for fixed data under varying distribution. So, to explore the concept further, just encourage viewers to check out this state quiz on deriving the maximum likelihood estimator for exponential distribution. The video concludes with his classic enthusiasm as the calibrate celebrates understanding this fundamental yet often misunderstood concept. Okay, thank you for watching. Bye bye.